Welcome to integrate this trigonometric function. How do we integrate ln x with respect to x from 1 to e? Without further delay, let us begin. This equal to integral from 1 to e. Ln x could be written as ln x times 1 ds. We are going to integrate this function using integral by parts. Integral by parts formula says integral of u dv is equal to the product uv minus integral of v du. By comparing, you will notice that our u is ln x and the v is 1 times ds. So let u equal to ln x and the v equal to 1 times ds. Differentiating both sides with respect to x, we have du ds equal to 1 over x. Whenever we differentiate ln x, we have 1 over x. And our goal for this guy is to obtain v. Let's just simply integrate. So we have integral of the v equal to integral of 1 ds. This implies that if we cross multiply here, ds times 1, that is ds, equal to x times du, that is s du. Dividing both sides by x, we have ds over x equal to x du over x. X cancels x, we are left with du equal to ds over x. Take note of this guy. Now back to this. Integral of the v, that is simply v, equal to, whenever we integrate a constant with respect to a variable, we get that variable. So integrating 1 with respect to x, that is simply x. Take note of this guy also. Now back to the integral formula. Integral of u dv equals to uv minus integral of v du. Let's continue. Integral of u dv equal to uv minus integral of v du. This implies that we have integral from 1 to e. What is u? Our u is ln x and our dv is 1 times ds, which is simply ds. So we have ln x ds equal to, let us just put it down here. Our u is ln x, dv is 1 times ds. What is u? U is ln x, so we have ln x times, what is v? We already have it, let me show you. V happens to be equals to x, so we have x. Evaluating from 1 to e minus integral of our lower limit and upper limit, 1 to e. V is what? V is x. So we have x here also. And what is du? Du is simply ds over x. So we have times ds over x. This equal to ln x times x, that is x times ln x. Evaluating from 1 to e minus integral from 1 to e. X takes care of each other, we are left with ds. This equal to, the upper limit here is e, so all of this becomes e times ln e minus, the lower limit is 1, so we have 1 times ln 1, close bracket, minus, don't forget that there is 1 here, since x cancel x. Integral of 1 with respect to x, that is simply x. Evaluating from 1 to e, we have 1 to e. This equal to e times ln e can also be written as ln e to the power of e minus 1 times ln 1 is simply 0, close bracket, minus, the upper limit here is e, so we have e minus, the lower limit is 1, so we have 1. This equal to ln e to the power of e, that is simply e, minus 1 times 0, that is 0, minus e minus 1. This equal to e minus e, that is e, minus times e, that is negative e, minus times minus 1, that is plus 1. This equal to e minus e, that is 0, plus 1. Clearly, this is equals to 1. Therefore, we can now claim that integral from 1 to e of ln x ds is equal to 1. This is the required solution. That's it. Thanks for watching.